Okay, my wonderful students, let's begin lecture. And to start, just a little note, a word to the wise. We have an exam, number 3, coming up a week from today. And so it'll cover everything that we've talked about in the last couple weeks, up to and including Thursday. And Thursday we're going to be talking about comets. And for that reason, I want to mention to you that your homework tonight is to read in detail the chapter 13 sections on comets. Over the weekend, I told you to go ahead and skim it because I didn't think we'd get to comets today, and we won't. But Thursday, yes, we will. And we will have some deluxe calculations of isotope ratios on Thursday. Probably you'll have an isotope ratio to calculate on the exam. So just so you know what's ahead. Item 6 on today's outline, Wild 2, is the name of a comet that we're going to look at in detail on Thursday. All right, now it's probably not mentioned prominently in the textbook, but if you want, just go ahead and in addition to the finishing chapter 13 on comets, reading carefully, just read whatever you can on Comet Wild 2. Now there's a lot of technical stuff over there, so if you see a lot of equations and stuff like that, go ahead and skip it. But there's a lot of cool news-style articles, news-type articles on Comet Wild 2. And that's how I pronounce it. Supposedly, it's a German guy, and so it's supposed to be pronounced Wild 2, but I always pronounce it Wild 2. Anyways, but mainly what we're going to talk about is asteroids today. And we do have some gravitational wave news. But before we do that, I want to reinforce a couple things about clickers. We put up clicker pointage last week. And boy, it seems like a whole week since I've seen you guys. But it's just been a long weekend. Anyways, we put up clicker points, and a few students said, "Hey, Dr. B, I only have 11 out of 15, or I only have 1 out of 15 answers. And what's going on?" And, I've been talking to students, and some students have figured out a couple things that they're not doing. And one of them is they're not on the right frequency. So if you have another class with another frequency, they may be using AC or BD or some other frequency. So if that's the case, you're going to have to change frequencies each time you come into this class, and then when each time you go back to that other class. Now the way that you do that is you hold down the red power button until it flashes in the upper left where you see DD there. And then once it starts flashing, you type in DD. And then it'll get a check mark, and you'll get a Go Nitro message, and that'll mean you're on my frequency. Now, if you don't do that, you're going to be SOL, which is a Latin abbreviation for the concept that you are toast. All right? Because you've got to be on my frequency. And I've gone over this about 9 zillion times the first half of the course, but it seems like we still need a little reinforcement on that. Another thing, make sure you register. And what that means is you've got to register through web courses. You just have to. If you register through iClicker.com for another class, that's lovely, but it's not going to get you on my roster. We have 600 students. We have to go through web courses, and so iClicker.com does not cut it for me. You've got to get on that roster. All right, and the only way to do that is through iClicker or through web courses. Now, a couple of you have promised to show me screen grabs or screenshots from your registration page. And I know that a few people, it's kind of blooped up. You've got to send me that in messaging. All right, so that may also be a reason that you're not getting anything, or you've only got a few answers on the books. Another thing, when I tell you to hit the refresh key, you've got to do it. All right, and if you come in late after I tell everybody else to hit the refresh key, you may be SOL. All right, so now the reason that you have to hit the refresh key is if I go from multiple choice to numeric input, like I'm asking you to type in, 2.7, and the previous question was A, B, C, D, and E, where you just hit the number, you have to change modes of your computer, of your clicker, or your clicker has to answer differently. And you tell it to do that by hitting the refresh key. All right. Now, any questions about that eye-clicking business? Okay, let's keep going. There was some gravitational wave news yesterday. Kind of interesting. I saw some in the newspapers. I went to the two very nice journals called Science, published in America, and Nature, published in England. Here's an image from a telescope in South America of something they call a kilonova. Kilonova. And what it means is it's a nova detonation that has been hypothesized, and it's a collision of neutron stars, we think, and we'll be studying neutron stars in a few weeks. And this is a picture in the visible band. Now, the important thing is that for this collision, explosive detonation, it's close enough that we were able to measure electromagnetic and gravitational waves for the same event. And so it's pretty important. Now, I've set up a couple articles linked to the additional readings page in web courses, and they're news level articles. So they'll refer you, or they'll have links to the fancy technical articles, if there are any. But for the most part, they should be legible and comprehensible to you guys. One is in Science, one is in Nature. And just go ahead and read that stuff as well, and anything else about that you wanted to read. In the Science article, there's some pretty good illustrations. Here's one of them. And this is the additional readings page in web courses. I linked it up this morning, and so it's ready for you to go ahead and read up on that stuff. Here's where the kilonova, gravitational waves, and gold. Both articles are emphasizing that this discovery is also important because it unravels, we think, or will unravel, we think, the exact procedure by which all the elements that are actually heavier than iron are manufactured. So iron, we think, is manufactured in the center through nuclear fusion, fusing bigger and bigger nuclei in the center of a star. A big star will fuse all the way up to iron. Our sun will probably not fuse that high. But our star will fuse carbon and nitrogen and oxygen. Probably is doing a little bit as we speak. But probably not iron. But bigger stars, yes. But above iron on the periodic table, it's kind of shaky. We have an idea. It's got to be some kind of a fancy nuclear detonation in a supernova or something else. And now we see this one fairly close so that we can knock out, or we can eyeball the gravitational waves and the X-rays, the gamma rays, and then the visible, which is, kind of a nice. And here's this diagram here kind of shows you the structure and why they're so jacked up about it. So all the gold that you have, if you have a gold filling, if you have, most telephones and computers have a little bit of gold because it's a very good conductor. You could put a very thin film of it for, it costs more, but if it's thin, it doesn't cost a whole lot more. But it's still a good conductor. So you see gold on stuff and everything, platinum, uranium, all the heavier elements we think are manufactured in these supernova explosions. Now, last thing I want to mention to you, I put that on the additional readings page, but it won't be on exam 3. All right, so save that. Go ahead and dip into those articles if you feel like it. It is kind of interesting to read about, but I won't lecture on it until after exam 3. So that's kind of a sneak preview into the future. All right, questions about the readings? Do you have your clickers ready? All right. Now let's talk about asteroids and stuff, chapter 13. I love this picture. Although these dots, these are single pixels probably, I'm guessing, in the original graphic. And even those pixels are way bigger than an actual asteroid would be if you could see it. You wouldn't be able to see it on this scale. So the asteroid belt looks like it's like extremely dense and stuff and dangerous to fly through, but we found that it's not. You can still run into one of those babies, but it's not like this. They only make the pictures look like this if they're, so you can see where the asteroid belt is. Anyways, different groups, classes at different distances from the sun. So the stony S-type is at about 2.2 AUs, and the C-types tend to be a little bit further out at about 3.2. Now there's a diagram in your textbook about that. And that seems to be in the, the kind of the donut-shaped asteroid belt itself. But then out in the orbit of Jupiter, there are two other groups called the Greeks and the Trojans. So the Greeks are out here, and let me get my cursor over here. Here we go. The Greeks are over here in the lower right, and they're in front of Jupiter. Jupiter's circling counterclockwise in this diagram, and then the Trojans are over here. And they just gave that as, like from Greek mythology, what do they call that? The Iliad, the war between the Agamemnon and the Trojans, the people of Troy. And so two opposing classes. But now the reason that the Trojans and the Greeks are out there, if you were to trace a line from like the center of the Greeks to the sun and out to Jupiter and then back to the Greeks, you'd form a 60-60-60 equilateral triangle. And the same thing up here with the Trojans. So from about the center here into the sun and then down to Jupiter and then back up here to about the center of the Trojans on the left of this orbital diagram, that's supposedly a 60-degree triangle. And those spots in Jupiter's orbits are known as Lagrange points, and they tend to be things that are in that location and orbit on that tend to stay there. It's fairly stable. And every planet has Lagrange points, We have Lagrange points, and in front of us and in back of us on our orbit, and I think we've got a couple spacecraft out there right now as a fairly stable point. Now, this other group, the Hildas, these are in what we call an orbital resonance. They're on highly elliptical orbits, and every 3 orbits, they're out there at aphelion the same time as Jupiter is out there. So they're near Jupiter at aphelion every 3 times they go through aphelion. So they're in an orbital resonance, and then there's another bunch over here by the Trojans and another bunch over here down by the Greeks, where they have their aphelion synchronized out there to, Jupiter every 3 times they go through I think it's an orbital resonance of 3 to 2, if I recall correctly. So every 2 orbits of Jupiter, there's 3 orbits of the Hildas, so they get synchronized up. And so that's the story of the asteroids. Really is the story of Jupiter. The asteroid belt exists because Jupiter is so close by, and as you'll read in the textbook in other places, Jupiter is so close to the asteroid belt that all the rock and metal and stuff that are in the asteroids, they never got a chance from the beginning of the solar system up to the present day. They never got a chance to solidify into one big object. Now, we got Ceres out there. Ceres is fairly good. It's a dwarf planet. It's in the asteroid belt. Vesta's pretty big. But they're not regular planets. And we don't think that it would be a very big planet. If all the asteroids were scooped together, by us, and shoved together into one blob, it would be, I think they think it would be smaller than the moon. So it's not a lot of material. It's not like another Jupiter. It's not like another Earth. It might be more like a small moon worth of material in smithereens out there. All right. Now, here's a blurb that I want to talk about at length, and that's the Near-Earth Asteroid Rendezvous mission, the NEAR spacecraft, which orbits a stony S-type asteroid called Eros. And as you know from the textbook, it became a temporary moon of this asteroid. It orbited that asteroid 6 ways from Sunday because the Eros asteroid is fairly good sized, but it's not a sphere, like Ceres. Ceres is fairly close to a sphere. It's round. But here's a picture of Eros. This is figure 7. And what they found after orbiting it, they found that it is actually a solid piece of rock. It's not a rubble pile. A lot of the asteroids and even the comets, they think, are more like rubble piles. Piles of rubble and trouble, rocks and dust and bulls, held together fairly weakly by their own gravity, and not held together coherently or cohesively by chemical bonds that make a rock solid. Granite is a solid rock. Brick, in the side of the walls here is solid because of chemical bonding of the silicate minerals together, and then the concrete, the mortar, that's a chemical reaction, and those are chemical bonds, and that's what makes it solid, and it makes it shapeable like that. But we don't think that all asteroids are like, but Eros is. Eros is it's a fragment of something, and I don't know if they've figured out exactly what it's a fragment of. But you can see it looks kind of like a, I don't know, kind of a weird looking potato. You know, and sometimes you pull potatoes out of the garden, you know, they're pretty weird looking. This one, you know, what I always think of is it looks like a, what do they call those shoes that ballet dancers wear? Dancing shoes, I guess. Slippers or, anyway, yeah, that's, what was it now? Point shoes. It doesn't look like it in this view. This looks like, to me, I look at this and I think, oh, that's the ballet's point shoe upside down, and the toe is pointing up and away from us. And the heel of the shoe is near us. And right here, see this kind of carved out area here? That's kind of important because that's where the foot goes into the point shoe. All right, and then down here, see where this kind of crater is here? It's a pretty good sized crater. If this was a ballet shoe, it would signify that she wore the sole of her shoe down to zip zap. She's probably got a blister. All right, so this is like I always think of it as, here's the sole of the shoe, here's the heel, here's where the foot goes in, and then the toe is over here. All right. Now the Eros satellite, or excuse me, the Eros asteroid, we've studied the you-know-what out of it. And we know a lot about it. Matter of fact, we even landed the Near Shoemaker spacecraft on it back in 2001. And by God, it still worked. It wasn't designed for a soft landing. You know, like these rovers that we have up there, you know, we put those things down on Mars and try to make it as soft a landing as possible. Sometimes it doesn't land very soft and we lose the spacecraft. But this one, they were just, the Near Shoemaker spacecraft was just designed to orbit, and it did a great job with it. You know, relaying back all that stuff. But then they decided, let's give it a shot. Let's see if we can because when you orbit, especially an object like this, shaped like a potato, you have to map out the gravitational field inch by inch, foot by foot, for every orbit. But eventually, if you do a bunch of orbits, as the Near Shoemaker spacecraft did, you'll know the exact strength of the gravitational field pretty much everywhere. And so you can figure out if, you know, look at your fuel, that, you know, they had to have a little bit of fuel left in the maneuvering rockets. All right? And then they thought, okay, let's see if we can get this down. And what they did, if you look at it, they got it into the shoe. You see the toe here's the toe right here. All right? And here's the heel. And in this picture, you can't really see that the crater. There's a big crater here where she wore out her shoe and she's got a blister. But here's where the foot goes in up here, and that's where they landed it. And it's great. It'd be like, it's like landing the Hubble Space Telescope, which wasn't designed for anything other than staying in orbit. It'd be like landing the Hubble Space Telescope and then keep looking through to the telescope. Well, this spacecraft, it's still up there. And, you know, they shut it down, but it's still up there. And it'll be there whenever they need it. You know, so if Bruce Willis comes out of retirement to save the Earth, he might need that thing. You know what, that would be a cool story. How I say, you know, for a movie, how I saved the Earth by using the long-lost Near Shoemaker spacecraft as my rendezvous point. The rendezvous with destiny. Anyways, it's still up there. By God, what a machine. You know, NASA and the European Space Agency, oh my goodness, some of these spacecraft they put up there, oh my goodness, they are fine, fine machines, fine spacecraft. Question?
Yeah, how old do they think that this asteroid is?
You know, I don't know the answer to that. I'm sure somebody does. You could probably look it up. But It's pretty, it's got plenty of craters. So using, well, let me keep going and we'll talk about cratering and stuff like that. But probably somebody knows, I don't know. Go ahead, continue.
Do they think that this asteroid could be like when the object that crashed into Earth that created the moon? Do they think it could be remnants from that?
The question was, do they think it could be a remnant, a smithereen, if you will, of the object that slammed into the Earth and created the moon, which we think is what happened, the giant collision? And the answer to that, probably not, because it is so far out past the moon's or past Earth's orbit, right? But it's probably, it's solid. So it's probably a fragment of something. It might be a fragment of, out there, it might be a fragment of Mars or a fragment of one of the moons of Jupiter. But probably not a fragment of Earth, our moon, or whatever it was that collided to form our moon. Question?
Do you have a size comparison for those?
For the Eros?
Yeah. Could like a human walk across it in like a day?
The question is there a size comparison, banana for scale, etc.? And could you walk across it in a day? And I think it's a little bit bigger than that, but not much. So it's maybe a couple days walk. But the gravity is so weak that you could probably, you'd be in a spacesuit that the Apollo astronauts, the shuttle astronauts wear. So you couldn't, be dancing up there very good. But if you do it, hop, skip, and a jump, you might be able to make it pretty. Although the other thing is, it's so weak, you might jump right off the planet and out into space. That wouldn't be very fun. And you'd be, permanently orbiting it. So you get a good size comparison that way. But I think it's fairly small. It's one of the bigger asteroids, but not as big as Ceres. That's the biggest.
Is it like Orlando size or is it?
I don't know that. I don't recall the exact size, but I'd guess it's probably Orlando size, maybe. But I'm sure you can look it up. That's good. I should have done that myself. I usually do. And I've got some other size comparisons, but I don't have one for Eros. Now, as I mentioned, asteroids get cratered, generally not round. Asteroids, if they are a rubble pile, but they're not big enough, they won't form themselves into a spherical object. They'll still remain, potato-shaped until their next big collision. And until they get a big collision, they'll acquire and accumulate craters. All right? So you can get cratered up even if you're loose. Now this picture here, this one, what is your name again? Sievert? Siever? This one you can see the kilometer marks here. And so I don't think Eros is much outsize these two babies. I don't think this is Eros here. It might be. I think it's a different one. But if it is, there's 2 kilometers down there in the lower right. So that would mean, maybe Orlando sized. Now, clicker question for you. Go ahead and turn your clickers on. And this is a straight recall question. Crater counting indicates that Gasbret and Ida formed. Go ahead and read carefully and answer. Go ahead and pop out the histogram. 30 seconds. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Go ahead. Okay, switch to the computer display for a second. Okay, the correct answer is C, 200 million years ago, and that was in the reading. And it's actually part of my comments, part of my notes on the reading. And I want to draw your attention to option B. Okay, switch back to the laptop, please. A lot of you chose option B. That's 4.5 billion years ago. Now, that's a tempting answer because that's roughly the age of the solar system, we think. But that's not the age of these two asteroids. We think they were formed a lot. They're fragments of something, and probably somebody has an idea what they're a fragment of. I mean, we have fragments of Vesta that we've definitely identified, but and I think we have fragments of Ceres as well that we've identified. We have fragments of Mars, we have fragments of the moon, but I don't think they know what those ones are fragments of. Ceres, let's talk about Ceres. It's one of the few asteroids that is round. Most of them are too small to form a round shape. This one's big enough, and it's actually not quite round. It's an oblate spheroid, 974 kilometers by 910. So the major axis is like the, so here's your size comparison, Seaver. The major axis for Ceres is like the distance from Orlando to Nashville, which is pretty big. If it were to hit Earth, it would be a ginormous disaster. Here's a picture of an oblate spheroid. No, this is a circle centered on Chicago, of the same diameter, 960. So that's about how big, for comparison, Ceres is compared to our planet. And if we backed up so that you could see the entire, you could still see this red circle and the entire disk of the Earth, you would see that that's actually pretty small compared to Earth. But for asteroids, it's the biggest. All right, now here's a couple cool images from the Hubble Space Telescope, and we've got the Dawn spacecraft up there right now orbiting Ceres, and these bright spots, we're trying to figure out what those are. Here's a picture of Vesta. Vesta is, does Vesta look like it's been demolished? It maybe used to be slightly round, but then it got clipped by a reckless driver in the asteroid belt, and almost half of it's blown away. Yeah. So let's keep it. So this is Vesta, but Dawn is go ahead and make a note. The Dawn spacecraft has orbited Vesta, but now it's orbiting Ceres. And we're looking at those bright spots, trying to figure out what those are. And we're analyzing the you-know-what out of Ceres now. And we have analyzed the you-know-what out of, this is session 16, lecture 16. We have analyzed the you-know-what out of Vesta. Matter of fact, here's some notes, some additional notes on Vesta. This one is a meteorite. It is a fragment of Vesta that got blown away perhaps in that collision that, blew most of it apart. And this fragment orbited in the solar system for a while, and then a few million years, and then eventually came and fell to Earth. And it's called Moore County because it fell in Moore County, North Carolina, back in 1913. And it's a piece of rock. It's a rocky meteorite. And we have meteorites we know are from Mars and stuff, but this one we know is from Vesta. I want to challenge you, everyone in here, when you're out and about here in Florida, it ought to be fairly easy to, if you can find a meteorite, if you're out walking, actually I should say it ought to be easy, but because we have all these woods and forests and swamps, it's probably not easy. But this one was captured was taken in Moore County. Somebody saw it come down. They went out into the woods and found it. Because it probably set a tree on fire, maybe a whole patch of woods on fire because it's burning. You can see, look at it. It looks like it's streaked from re-entry. It looks like looks like one of the Mercury spacecrafts after re-entry. Those streaks. The easiest places on Earth to find meteorites are Antarctica and the Sahara Desert. And the reason for that, there's nothing special about, like them being a magnet or anything. It's just that if something falls to Earth and it's on the surface of an ice field, chances are if it's dark like this, it's going to be fairly easy to see. Same thing in the Sahara Desert. You're out there in the desert, and there are places in the desert where there's dark rock like this. This is a dark basalt-like rock. But there's other places where it's very light. So if you don't see it come down to Earth in your neighborhood and start a tree on fire so you know exactly where to go, but if you are wandering around, the reason it might be easier in Florida is the entire state of Florida, the bedrock is limestone. And it's a light-colored limestone. And other than that, we have a lot of sand. And that's really light-colored as well. So if you see a dark stone, and it looks like a stone, and not something that came out of the south end of a northbound cow. Right? So don't be tricked by cow pies or anything like that, which has happened to various people. Oh yeah, look at this asteroid, but it's actually, something else. But if you see a dark colored stone in Florida when you're out and about, definitely, because there's no bedrock that's dark colored here. So unless you're near, a construction site where they're using, like along the railroad tracks, they use a dark colored stone for ballast, usually. But if you're not near any place like that, if you're just out in the woods somewhere along the beach and you see a dark colored stone and it's not fossilized, it's not fossilized, then you might have an asteroid. Actually, a meteorite that is possibly a fragment of Mars or possibly a fragment of an asteroid. Now, the reason I bring that up is this. These things are rare. So if you find one, it is extremely valuable. All right? So you could sell it to, like Professor Britt in the physics department here he would pay dearly for a gram of it to study. And he would love to have the whole hunk of rock. When I lived in St. Thomas in the Virgin Islands, I was talking to one of the guys in St. Thomas, and he had lived there his whole life. He worked in the science building. And he was telling me a story how when he was a young man, teenager, he and his dad saw a meteor fall to Earth, and they saw where it hit because it hit a big oak tree down in St. Thomas, or a mahogany tree or something, and it split it and set it on fire because it was so hot. So they went out there and they tracked it down, and apparently it was this big. So the size of what's this big? Size of a watermelon. Right, so maybe the size of a watermelon. But he said it was heavy as you know what? Because it was metal. It was a metallic meteorite. And I said, well, do you still have it? Because it's extremely valuable. You'd be a millionaire, with that thing. He said, oh no, we used it. We just brought it home after it cooled off, and we used it for a doorstop. I said, do you still have it? He said, it's still at your dad's house. He said, no, we threw it away a long time ago. Can you believe? He didn't know. But now you guys know. All right? So if ever you see some fire in the sky, and then a fire in a tree, and you go to the tree and you find this watermelon, or even a baseball-sized hunk of metal, if it's not from a spacecraft, see, when he did it, he was an older guy, and so it was back in the 40s or so when he saw that. Before there was spacecraft coming. So you might find a piece of orbiting space junk that falls to Earth. That's possible. But if it's not that, if it's a meteorite, oh baby, you hold on to that. You call me up, and I'll help you. I'll help you find a seller or a buyer for it. Anyway, so this is Moore County, and it's up there in Moore County. They have a museum just for this meteorite. It's pretty cool. I'm going to have to go up there on a field trip once. Eucrite, that's a fancy mineral name. It's similar to basalt. Basalt's very common on Earth. It's the rock that underlies most of the ocean floor. And we see basalt in some rock formations here in the continent as well. But definitely very common on Earth. And here's the cool part. The crystals, when what they do is they take a really good saw and they saw off a very thin, small, but very thin slice of these meteorites. And then they analyze it, like under a microscope. They shine ultraviolet light on it. They shine X-rays on it. They shine infrared on it, see what fluoresces. And they analyze it that way and stuff. And so the crystals in this one indicates that it was in a magma chamber, like down below Yellowstone National Park. There's a big magma chamber, Mount Vesuvius. All your volcanoes around the Earth, the active ones, they've got ginormous magma. Well, some of them are ginormous, like Yellowstone. Other ones are not so big. But they have magma chambers underneath. And when the magma chamber gets too hot and too full, excuse me, the volcano will blow. Okay, and that's where they think that this thing solidified. So if a volcano is dying and cooling off and it's not going to blow, that magma chamber is going to cool slowly. And anything that cools slowly, the crystals are going to be big and nice. And the size of the crystal here on Earth, we know, means big crystal cooled slowly, deep in the Earth. Small crystal cooled quickly, or glass cooled extremely quickly near the surface. So this one they think was deep in a magma chamber. In Vesta, or whatever the parent of Vesta was. So we think maybe Vesta is a fragment of something else that had magma, like Mars, magma chambers, or it has its own magma chamber from when it was a round spherical object. So it's, I don't know, there's a lot to learn. It's kind of cool. I mean, you could spend your life, even as an amateur astronomer, an amateur asteroid buff, looking at these things and stuff. And there's many other asteroid groups that are similar to this. So we know that there's a lot from Vesta. There's a lot from Mars, several from Mars that we know. Other planets and moons and stuff. NWA 7304, let's talk about this one for a minute. This one we definitely know is from Mars. NWA 7304. And this one is, they nicknamed this one Black Beauty because it's a black rock. And you can see in this photo, the scientist, you can see it's, for scale, Seaver, it's not even the size of a baseball, maybe the size of a tennis ball or so. Okay, and it's a fragment. It's not a round blob or anything like that. And the grayish face of it facing you is where they shaved or they sliced off a few slices of NWA 7304 in the laboratory. and then analyzed it. And you can see that in there are little fragments. You see those little light colored and darker colored blobs in there in the part that's shaved off? The outer coat over here that wasn't sliced off over here, that looks like it was burnt. And that's what typically happens to these rocky ones on the way into the atmosphere if they don't break apart on re-entry or entering the atmosphere. They'll end up with kind of a blackened crust. But this one, then you can see what's on the inside, and you can see that this is gray on the inside, but it almost kind of looks like, like a pudding, with different, or what do they call that stuff? Fruitcake. With like little, or like that stuff that your grandma makes, Jell-O with little fruit cocktail embedded in it. So raise your hand if you've ever seen that, Jell-O with, fruit cocktail. Yeah, I don't know why they make that stuff, but anyways. So this looks like, here's like the fruit cocktail, except it's not fruit, it's like different kind of minerals. And they've now had enough spacecraft up on Mars and analyzed enough rocks up on Mars that they know that this was also a fragment of the dark plains, some of the darker areas of Mars. Yeah, NWA 7304. Blasted off Mars, orbited in the solar system, easy as possible, and just happened to blaze down and hit on the surface of Earth, and somebody in Morocco, they think, picked it up. And everybody over there in Morocco, all the guys that live out in the desert, all the people out in the desert, they know that if they find anything like this, that the city slickers in Marrakesh and all the different cities in Morocco will pay big dineros for these babies. So they're all looking for them. But they think somewhere in Morocco they picked this up. This one they don't know exactly where. Sometimes they do know exactly where, and what they really want to do is go back and find some more. So if you know where this one was picked up, and you can go back out there with your buddies and ride around in your Jeeps or camels or whatever you're riding on, motorcycles, and scour and look for some more and make some more money. And hopefully unravel the mysteries of Mars. So NWA 7304. Now, I have another one that I want to talk about. It's called Allen Hills 84001. There it is. It's orthopyroxenite, igneous. But some scientists think that ALH 84001 has a fossilized life form in it. Now, here's the fossilized life form that they're thinking about. Look at that. Eyeballs. Eyeballs off your computer screen. Look at this. Look at that thing. What does it look like? You ever seen anything like that? Looks like a what? Huh, coral in a coral reef. You're right. I always thought it looked like a worm, you know, some disgusting slug or something like that, but coral in a coral reef. So what they did with Allen Hills 84001, you can see here that they shaved off a face of it right here. And here's the size of it. Here's a meter stick. And this cube here is 1 centimeter. And they know it's from Mars. So make a note, Allen Hills 84001, we know it's from Mars because it has tiny little spheres of glass. When this thing was blasted off the surface of Mars, it was so hot that part of it melted. And then it was ejected into the atmosphere on its way to Earth eventually. And as it rose through the atmosphere, it cooled off really fast. And so that forms glass. If you have something that's molten, you know, if you could take some molten lava and cool it off in like a second, a lot of times, depending on the composition of the lava, it will form glass. Because glass is just silicon dioxide, and there's a lot of silicon dioxide in these rocks and stuff, even on Mars. And so they have these little glass spheres. And inside the glass spheres, you know what's in there? Go ahead and make a note of this. The glass spheres in Allen Hills 84001, little bubbles. And in those bubbles, the atmosphere of Mars. Yeah, it trapped a little bit of air. The air of Mars. In those bubbles of glass, which formed right after impact. And so what they did, they found these glass, called glass inclusions, or bubbles of glass, and they drilled really carefully, and they extracted the stuff in the bubbles inside the glass. They extracted the little bit of atmosphere really carefully, and they analyzed it. And it had the same mixture of carbon dioxide as Mars. Everything, you know, isotopes, everything. And so they thought, dude, this is a Martian asteroid. And then somebody took a closer look at it, and they saw this. And they said, whoa, is that a life form, a fossilized life form on Mars? You know, it's one of those untold stories. We don't know the answer to that yet. Some people say, make a note of it. Fossilized life form in Allen Hills 84001 is a controversy. Some scientists look at this and other scientists and say, yep, definitely a life form. In other words, and other scientists say, no, I disagree. Now, that's why we have so many rovers up there on Mars. We're looking for water, and especially we're looking for signs of life. All right? Now, speaking of signs of life, by the way, let me go back to this picture one more time. The official name of this one is ALH 84001. all right? And that stands for Allen Hills. And Allen Hills is a big ice field, the Allen Hills ice field in Antarctica. And that's where they found this one. And they found a bunch of other ones. This is just number one in their bag of discoveries. Now, you guys are probably not going to be spending much time in Antarctica, although I hope you do get to spend some time down there if you get a chance. Same with the Sahara Desert. But if you're out and about here in Florida, keep your eyes open. You might find the real fossil life form from Mars. Now, speaking of life forms, we mentioned, and this is just to reinforce something I mentioned last week, on the planet Mars, scientists have found methane plumes, and here's some photographs and some false color images of the surface of a place called Nili Fosse, Syrtis Major, and Terra Sabaei on Mars. And this left panel shows the methane abundance. The thing about it is, it comes and it goes. So these guys, MJ Muma et al., this is something they discovered and measured in about 2009 based on one of the orbiting spacecraft. And they thought, this is seasonal methane. This is something that, just like on Earth, you get methane. Like if you're in a swamp and you get swamp gas, methane, you're going to get a lot in the summer. But if you're up, in a swamp that's up north that freezes in the winter, you're not going to get much swamp gas. And there's a lot of freezing and melting, we think, on Mars. So, they're thinking this might be, a form of life, because definitely methane is a sign of life here on our planet. But it forms, naturally too, without being organic life form initiated. Anyway, so you can look that one up in the journal Science, MJ Muma et al. In 2009. Now, preview of Thursday's lecture. To motivate you to finish reading in chapter 13, this is a photograph of the nucleus of Halley's Comet. Now, look at that thing. It's not round. It looks like a round, lovely, glowing dot when we view it from Earth, but this is from a spacecraft up close. And we maneuvered this a number of years ago, and it looks like an asteroid, but it's slightly different composition. All that glowing white stuff in the photograph that's clouds of gas, hydrogen, CO2, H2O, and they call that outgassing because it's getting close to the sun, it's warming up, and so it's evaporating and boiling off in the heat of the sun. Now, we're going to talk about comets on Thursday, and actually we're talking about them now, so this is the first part of your notes on comets. And here's a picture of some recent comets, and you can see that Halley's Comet goes just past the orbit of Neptune. And this comet over here, the green one, Hyakutake, came through about 20 years ago. And that one, I remember people taking photos of it. It has an aphelion way out beyond the Kuiper Belt. But now there's a couple down here in the inner solar system, Wild 2 and Temple 1. And if you look at these orbits, you'll see that that Wild 2 barely goes a little bit past Jupiter for its aphelion. So its major axis is a little bit bigger than its semi-major axis is a little bit bigger than the semi-major axis for Jupiter. And Tempel 1 as well. All right, now both of those come through the inner solar system all the time. And Wild 2 is the one that we're going to study carefully. These are what we call Jupiter family comets. So make a note of that. Wild 2 and Tempel 1 are Jupiter family comets. And we think that they originated out in the Kuiper belt, which is like the asteroid belt of comets. We'll talk more about that on Thursday. But then they kind of got captured by Jupiter. So now they're orbiting along with Jupiter. And they come down into the inner solar system every few years where we can see them. Okay? So now Wild 2 is the one that we're going to look at carefully because Wild 2 is the comet that we sent the Stardust spacecraft to fly through it. The tail of Wild 2, go ahead and make a note, Stardust spacecraft flew through the tail of Wild 2. And you see this kind of tennis racket object here, where the yellow arrow is? Okay? That's the collector. See, these are the solar panels, so that's like most spacecraft. And then here's the guts of it. Here's the radar antennas and stuff for transmitting. And then this tennis racket job up here is the collector. And this is what it looks like in the lab. And in each of those cells is a block of what they call aerogel. And it's a form of silicon. It's really light. And they were hoping to catch some of the fragments and dust in the tail of Wild 2 in those cells. And they did. And the Stardust spacecraft was designed to come back to Earth and jettison its capsule containing this collection unit. Right? Now, the Stardust spacecraft flew through the coma, or the tail of Wild 2. And it had its arrow. This is Wild 2. Here's Comet Borrelli. Here's Comet Tempel 1. Those are the nuclei, we think. That's what they look like. They look like asteroids, But anyway, so this is what Wild 2 looks like. And that is what we are going to talk about on Thursday. Wild 2 and comets in general, and Wild 2 in specific. And we're going to make some calculations, so make sure you are here and bring your calculator. Okay, you're dismissed. I'll see you on Thursday.